Suppose we have to visualize 3.765 on the number line. Very clear, 3.765 lies between two integers 3 and 4. But exactly where? For that we need to magnify the number line. So, as we can see in the diagram, 3.765 lies between 3 and 4. But exactly where? For that I need to expand that portion of the number line lying between 3 and 4. In other words, I need to magnify the portion between 3 and 4. So what do we need to do? We need to divide the portion between 3 and 4 into 10 different segments. 10 different segments means, let me clarify it, the 7th mark and the 8th mark of the subdivision of that corresponds to 3.7 and 3.8. Let me make it clear to you. When I am drawing a number line and this is my 3.0 and this is my 4.0, so where would this 3.765 lie? It will lie closer to 3.7 and 3.8. Suppose 3.7 is somewhere here and 3.8 is somewhere here. This is my 3.9 and here we have 3.6 and other numbers. So, in the beginning, I chose 3 and 4 with no decimal point. I am making it simpler. I chose 3 and 4. This was my step 1 with no decimal point. Then I inserted a decimal point and I inserted one digit after the decimal point. Then 3.765 will lie somewhere between 3.7 and 3.8. Let us see what do we have in the next step. Yes, the same has been shown with the help of a diagram. First, I chose the integers only 3 and 4 without any decimal expansion. Then I have written without any decimal expansion. Then this is written in place of 3. You may write down 3.0. Here in place of 4, I have written it in the form of 4.0 and the divisions are 3.1, 3.2, 3.3 till 3.9 and 4.0. So, from here I will choose 3.7 and 3.8 because the given number lies between these two numbers. Now, if I magnify it, next I have to take 3.7 as my endpoints. And I would suggest you to write it as 3.70 and 3.80. So, 3.76. First, I located 3.7 and 3.8. Then I located 3.70 and 3.80. So, next step is dividing 3.70 and 3.80 into 10 equal segments. And 3.765 will lie between 3.76 and 3.77. Next, I'll take these two as the endpoints. Again, I would like to add once more that keep on increasing the number of digits after the decimal point by inserting a 0. Here I have taken 3.76, make it 3.760 and make it 3.770. Now, 3.765 will lie exactly between 3.760 and 3.770. So, here is my 3.765, the midpoint. Next, we are going to start with operation on real numbers. When I am talking about operations, I am talking about the 4 mathematical operations which we all are very aware about. The 4 mathematical operations include addition, subtraction, division and multiplication that we all know and we have been learning from childhood. When I am talking about operation on real numbers, I apply operation on rational as well as irrational numbers. Rational numbers, we all know all the rational numbers be it integers, whole numbers, or any other rational number, be it decimal or fraction, they satisfy certain laws or properties. So all type of rational numbers, they follow such property. And what are these properties? Let us start with the first property of rational numbers. The first property, closure property. And we have come across this property while studying whole numbers also. Rational numbers are closure, they are closed. Closed means lying between a certain domain, right? Closure property comes from the word close. They are closed on addition and multiplication They are closed on addition and multiplication. That means the closure property is satisfied using addition of rational numbers and multiplication of rational numbers. Let us make you understand better what is a closure property. If I add two rational numbers A and B, the result will give you another rational number C. So, if A and B, they belong to the rational number Q, C also belongs to Q. This is the belongs to sign. So, A plus B, if A and B both belong to Q, C will also belong to Q. Similarly, if A and B belong to Q, if A and B belong to the set of rational numbers Q, then their product, if A into B gives you a product equal to C, then C will also belong to Q, which proves that the addition of two rational number will always result in a rational number. Multiplication of two rational number will result in a rational number. That is why they are said to be closed under addition and multiplication. They still remain rational number. They do not take any other form. They do not go out of their domain. The second property, but before we begin the second property, let us try that if I am saying that rational numbers are closed on addition and multiplication, why aren't they closed on subtraction and division? They aren't closed on subtraction and division. It is not satisfying closure property in subtraction and division. Let us see how. For example, if I take two rational numbers 3 and 4, 3 plus 4 will give you 7. So 3 is a rational number, 4 is a rational number, 7 is another rational number. 3 into 4 will give you 12. 3 and 4 are rational numbers, 12 is another rational number. So, the property is satisfied. But if I take subtraction, for example, if I write 3 minus 4, it will give you minus 1, whereas 4 minus 3 will give you, 3 minus 4 will give you minus 1. Repeat. 4 minus 3 will give you plus 1. 4 divided by 3 will give you a rational number. 3 upon 4 will also give you another rational number. Let us discuss operation on real numbers. Rational and irrational numbers, they satisfy all the properties that we have learned so far in our junior classes of numbers. The properties of whole numbers, the properties of natural numbers. So, which properties were they? Let us recall. Starting from commutative property. Let us recall what is commutative property. All the rational numbers and the irrational numbers satisfy commutative property over addition and multiplication, means that the numbers are commutative on addition and multiplication. Explaining it further, commutative on addition means the order of the numbers will not alter the sum. Speaking about multiplication, the order of the numbers do not alter the product. This we have already seen. For example, if I add two rational numbers, 3 and 4, it will give me the same result as 4 plus 3 equal to 7. So we can see that rational numbers are commutative on addition. Again, if I multiply 3 and 4, it will give me the same result if I multiply 4 by 3, that is 12. So we see that even if we interchange the places of the rational numbers, the sum or the product, they remain same. But let me remind you once again that the numbers are not commutative on subtraction and division. If I subtract 4 from 3, I'll get 1. But will I get 1 if I subtract this? If I am subtracting 3 from 4, I'll get 1. But if I am subtracting 4 from 3, will I get 1? No, I'll get minus 1. This shows that the rational numbers, they are not commutative on subtraction. Similarly, for division, 4 upon 3 is not equal to 3 upon 4. So that means if we change the order in subtraction and division, obviously the results would not remain the same. Hence, the rational numbers are not commutative on subtraction and division. Next property we have discussed. What is commutative property? Now let us discuss associative and distributive property. Let's take a quick recap. Associative property: if I add a rational number A to a sum of rational numbers B and C, it will give me the same result as adding the set of first two rational numbers to the third one. What have I done? I have first added the last two and added the sum to the first. It will give me the same result if I take the sum of the first two and add it to the third. This holds true for multiplication also. If I multiply A with the product of B and C, it will give me the same result if I multiply the product of A and B to C. It's true in case of addition and multiplication. Again, associative property does not hold true in case of division and subtraction. The last property is distributive property, which has its large implication. And distributive property is quite useful in adding and multiplying large numbers. Let us have a quick recall about distributive property as well. Now, distributive laws or distributive property. Distributive property states that if I multiply a number with a sum of numbers, it will give me the same result as multiplying the two numbers and then taking the sum. Let us now discuss distributive laws. Let's take a recap of distributive law. Distributive law states that A into B plus C will give you the same result as A into B plus B into C. It has its wide use. Let's take an example. Suppose I have to multiply 4 with 206. 206 is a large number. So what I can do, I can split 206 into two parts, 200 plus 6. and then multiply this with 4. Now splitting it into parts will make my calculation easier. Using this law, 4 into 206 can be written as 4 into 200 plus 4 into 6. So this would give you the same result as this, and we know that 4 into 200 plus 4 into 6, operating this is much easier. So that was a recap part which we have already done in our previous classes. So rational and irrational numbers, both of them satisfy commutative, associative and distributive laws for addition and multiplication only. But the sum, difference and product of rational numbers, we know they result to be a rational number only. If I add two rational numbers, I know I'll get a rational number. If I multiply two rational numbers, I know I'll get a rational number. If I divide two rational numbers, I'll get a rational number. If I multiply two rational numbers or subtract two rational numbers, the difference will also be within the domain of a rational number. It may come out to be a negative. If I subtract 4 minus 3, I may get a positive 1, and 3 minus 4, I may get a negative 1. But both positive 1 and negative 1, they are rational. But in case of irrational numbers, the sum, difference and products of irrational numbers are not always irrational. As we can see here, this point is very, very important. This is true not for rational numbers but for irrational numbers. For rational numbers, the sum, product, difference of rational number always is a rational number. But for an irrational number, it is not always so. Sometimes it may be true, sometimes it may not be. For example, root 2 minus root 2. It's a difference of two rational numbers, but is it giving you a rational number? No, it is giving irrational number. It is giving you a rational number. Root 2 and root 2 both are irrational numbers, but their difference is giving you a rational number. Again, root 3 into root 3. Root 3 into root 3 will give you 3. Root 3 into root 3 will give you 3. Root 3 and root 3 are both irrational numbers, but their product is giving you 3, which is a rational number. So again I see that the product of two irrational numbers may not be a irrational number. It turns out to be a rational number. Let us take few examples how to operate on real numbers which include both rational and irrational numbers. Suppose I have to add 2 root 2 plus 5 root 2 and root 2 minus 3 root 3. Just take this rational and irrational numbers as two different variables. So when we add variables, what we did? We grouped them. Similarly, if I treat the irrational numbers or the numbers under the under root as variables, simplification, the calculation becomes more simplified. So if I have to add these, just see how do we go. What I have done, I have just collected the like terms. Here by like terms, I means all the root 2's. All root 2's are like terms. So 2 root 2, I collected 2 root 2. Repeat. एक तो ये पेन नहीं select होता. So here are some examples of simplifying rational numbers. The simplest way of operating irrational and rational numbers is to group them. As variables. Let us take the irrational numbers as one set of variables and rational numbers as another set of variables. For example, if I have to add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. This is one set of number, this is another term. This is one term, this is another term. So what do? I group 2 root 2 and root 2 together. I told you to consider them as like terms. Consider them as like variables. So, grouping 2 root 2 and root 2, I get this expression. Then group 5 root 3 and minus 3 root 3 together, form another group. Consider this root 2 to be a variable which has to be kept fixed. I cannot do anything with it because it's fixed. So, taking root 2 common, if I take root 2 common, I'll have 2 plus 1 within the bracket. So, the answer becomes 3 root 2. Again from here, if I take root 3 common, 5 minus 3 will become 2 root 3. So, what have I done? I have just treated them as separate variables. Root 2 is one variable and root 3 is another variable. Similarly, if I have to multiply 6 root 5 and 2 root 5, again I'll collect the like terms, the similar ones. I'll multiply 6 and 2 because both of them are rational, and I'll multiply root 5 and root 5 together. So, here also in this step we can see 6 into 2 will give you 12 and root 5 into root 5 will give you 5. So, 12 into 5, the final answer will be 60. Let me give you one more example. Suppose in addition, I'll giving you one more example. Suppose I have to add 3 root 5 plus 2 root 3 plus 5 root 5. Again I am repeating, consider these irrational numbers as one term and the rational numbers as another term. So, first I'll collect all the irrational numbers of the same type. So, I'll collect 3 root 5 and 5 root 5 and add them together. So, 3 root 5 plus 5 root 5. Let me explain it more clearly. Let me consider this root 5 to be x and let us consider this root 3 to be y. Since they are two different variables, they cannot be added. Only the variables of the same type can be added. Since I have considered x to be root 5, so all the root 5s can be added together. So, 3 root 5 plus 5 root 5 will be grouped together and this 2 root 3 will be written separately. I can add these two because both of them have root 5. So, 3 root 5 plus 5 root 5 will give you 8 root 5. How did I get 8? I have taken root 5 common. Taking root 5 common, I will be left with, because I have considered it as a variable. So, as we take x common, here I have taken root 5 common. Taking root 5 common, I will be left with 3 plus 1, which will give me 3 plus 5, which will give me 8 root 5 plus 2 root 3. Since this is my x and this is my y, they cannot be added together. So, they are unlike terms, they cannot be added together. So, this is my final answer. Let me show you an example on multiplication. For example, I have to multiply 2 root 3 into 5 root 3. Here root 3 is a rational number and I denote it by a variable x. So, these two will be multiplied together. These two will be multiplied together and they 2 and 5 being irrational numbers, they will be multiplied together. 2 into 5 into root 3 into root 3. So, 2 5s are 10 into 3 will give you 30.